So the first one, normal approximation to binomial. We can use this when NP greater than 5 and N times Q greater than 5. Okay. So the original distribution is binomial. From binomial, we have the parameter N and P. So when we want to use the normal approximation, we need mean and variance. Okay, mean and variance. So mean here equal to NP and variance equal to NPQ. Mean NP, variance NPQ. So standard deviation, square root, variance, square root NPQ. Okay. So the Z formula also the same, X minus mean over standard deviation. Okay. Let's go through the example. Example 1. Example 1, we have the probability that a patient recovers from a rare blood disease is 0.4. If 100 people are known to have contracted, okay, so 0.4 is our P and 100 is our N. Okay, what is the probability? Less than 30 survive. Okay, we study on 100 people. We want to find the probability that less than 30 will survive. Okay, so the original distribution, is binomial. N equal to 100, P equal to 0.4. So NP equal to 40. Sorry, N times P equal to 40. Greater than 5, so we can use the normal approximation. Okay, use normal approximation. Mean equal to NP, mean equal to NP 40, variance equal to NPQ, NPQ 0.4 times 100 times Q 0.6. Okay, NPQ 24. Variance equal to 24 and standard deviation square root variance lah. Standard deviation equal to 4.9. Right, so the probability that we want to calculate is, what is the probability? Less than 30. Okay, so less than 30. First we need to do the continuity correction. Less than 30, less than, no equal. So we need to minus 0.5. Okay, continuity correction first, minus 0.5. So probability X less than 29.5. After we done the continuity correction, baru kita convert X to Z, Z. 29.5 minus mean over sigma. Okay, over standard deviation 4.9. So probability Z less than negative 2.14, right? Negative 2.14. Sorry, negative here. Negative 2.14. Okay, so from the table, after that, use the normal distribution table. From the table, we will get the probability is equal to 0.01618. Okay, so this is the probability. Example 2. Example 2. We have a multiple choice quiz with 200 questions. Each question have 4 possible answers, which only one is correct. Okay. So the probability that we will get a correct answer is, or P is 1/4 lah. Okay. Or 0.25. What is the probability that shear gets work from yield from 25 to 30 correct answers for 80 of the 200 problems? Okay, so 80 is the n equal to 80. From the 200 question, memang ada 200 question, but we want to just study 80 of the question, right? So n equal to 80, right? So the original distribution is binomial with n equal to 80 and p equal to 0.25. So p here is 0.25 times 80 equal to 20. Okay, 20. So greater than 5, we can use the normal approximation. Okay, we can use the normal approximation. So approximately normal distributed with mean equal to NP 20, variance equal to NPQ. Okay, NPQ equal to 15. So standard deviation, square root variance, or equal to 3.87. Okay, so the probability that we want to calculate is probability from 25 to 30 correct answer. Okay, probability from 25 to 30. Okay, from 25 to 30 ada equal so x greater than or equal to 25 until x less than or equal to 30. Okay, so first next we need to do the continuity correction. Okay, greater than and equal to 25 minus 0.5, so it will become 24.5. Less than and equal to 30 plus 0.5, so it will become 30.5. Okay, then only we convert x to z. Okay, 24.5 minus 20 over 3.87. 30.5 minus 20 over 3.87. Okay, so z value between 1.16 and 2.71. Okay. Sketch the area 1.16 and 2.71. Okay, so and then use the normal distribution table. Okay, so we will get 1.16 0.1230. Okay, minus 2.71 0.00336. Okay, so the probability is equal to 0.1196. Okay, so the method is simple. You need to do the continuity correction first and then baru convert the x to z, and then we can use the normal distribution macam biasa, use the normal table to find the probability. Okay, so example 3, 4 and 5, we can try this out later. I will just share with you the probability value. Okay, you can try to calculate the probability later. Example 3, probability x greater than 32 equal to 0.1446. Example 4, probability x greater than and equal to 50 equal to 0.2119. And for example 5, probability x less than and equal to 150 equal to 0.9808. Okay. So the last one, normal approximation to Poisson. Okay, so ini simple je, rule of thumb dia, senang je nak ingat. We can use normal approximation instead of Poisson when the lambda is large. Lambda is large is we consider lambda greater than 20 as large lah. Okay, lambda greater than 20 is large, so we can use normal instead of Poisson. Right, so to use normal distribution, we need the original distribution is Poisson. Poisson, we only have one parameter, that is lambda or the average. So to use the normal approximation, we need mean and variance. So for this case, mean equal to lambda and variance also equal to lambda. So standard deviation is lambda square lah, square root lambda lah, right? So mean equal to lambda, variance also equal to lambda. So Z x minus mean over standard deviation. So x minus lambda over square root lambda. Okay. Example 1. Suppose that at a certain automobile plant, the average number of work stoppages per day due to equipment problem is 30. Okay, so this is the lambda, the number of stoppages per day. Lambda equal to 30. Okay, so the original distribution is Poisson, lambda equal to 30. So lambda greater than 20 means we can use the normal approximation. Okay, what is the probability of having 20 or fewer work stoppages? 20 or fewer. So we want to calculate probability x less than or equal to 20. Okay, if you want to use the Poisson distribution, we need to plus F0 plus pi F20. It's not difficult, but quite a hassle to calculate this. So because lambda is big, we can use the normal approximation. So it is better for us to use the normal approximation because it is easier to calculate, and the probability, the answer also precise. All right. So if you want to use the normal approximation, mean equal to lambda equal to 30, variance also equal to lambda. So standard deviation equal to square root variance equal to 5.48. Okay, so we want to calculate the probability x less than or equal to 20. First, do the continuity correction, less than and equal. Okay, less than and equal, we need to plus 0.5, right? Less than and equal plus 0.5. Okay, so this one you need to remember lah. If not, when you just note it somewhere that easy for you to refer. Okay, so less than and equal plus 0.5. So meaning that probability x less than or equal to 20.5. Okay, and then we convert it to z. 20.5 mean minus mu 30, x minus mu, okay, 30 over standard deviation 5.48. So we will get the value z less than or equal to negative 1.73. Okay, so z less than negative negative 1.73. So it is equivalent less than negative, less than negative. It is equivalent to greater than positive 1.73. Okay, we don't need to do 1 minus. Just you can just take the value from the table right away. Okay, so we got the probability is equal to 0.0418. Okay, the second example, cars arrive at Kenny's car wash at a rate of 9 per half an hour. Okay, lambda dia 9 per half hour is 30 minutes lah. 9 per 30 minutes. What is the probability that in any 3 hour period, at least 18 cars arrive? Okay, so the lambda given here is for 30 minutes, half hour. So we want to calculate probability at least 13 for a 3 hour period. Okay, so we need to adjust the value of the lambda. So for 3 hours period, lambda is equal to 9 times 6 lah, 54. Okay, so lambda is large, more than 20. We can use the normal approximation. The original distribution is Poisson with lambda equal to 54 per 3 hours. Okay, so we can use the normal approximation. Normal, mean equal to lambda, variance equal to lambda. So standard deviation equal to square root variance equal to 7.35. Okay, we want to calculate the probability at least 18, so greater than or equal to 18. Greater than and equal, we need to do the continuity correction. Greater than and equal, we need to minus 0.5. So it will become 17.5. And then we convert x to z. 17.5 minus 54 over standard deviation 7.35. Okay, so we will get the z equal to negative 4.97. Okay, and then refer to greater than negative 4.97. So refer to the normal table. We need to minus 1 minus z 4.97. The probability is equal to 0.000002867. Okay, 0.9999. Okay, so try this example later, example 3 and example 4. Example 3, you will get the answer, probability x less than 27 equal to 0.6179. And example 4, probability x greater than or equal to 33 equal to 0.1977. Okay. So that's all for chapter 3 or for approximation. Ada 3 approximation. Poisson approximation to binomial, normal approximation to binomial, and also normal approximation to Poisson. Okay, so we have finished chapter 5. special distribution, or we actually have finished the syllabus, right? So after this, what you need to do is do a lot of exercise and revision for our coming test and quiz next week, right? So that's all. Thank you. Assalamualaikum.